So very good morning to all. Today we're going to see about first order logic in knowledge representation. So before that we have four subtopics in first order logic. The first one is representation and syntax and semantics of first order logics. So in the syntax and semantics of first order logic, totally we have 16 types of syntax and semantics. So we're going to see about all the 16 types of syntax and semantics. And third one is the using first order logics. So here we are going to discuss about what is meant by first order logic and examples of first order logic and three types of logics like objects and relations and functions. So we're going to discuss about three types of relations. And fourth one is the knowledge engineering in first order logic. So here we're going to discuss about what is meant by knowledge engineering, who are all the acting in knowledge engineer, and what are all the steps to be needed for the to perform knowledge engineering process. So totally we have 6 types and 6 methods in knowledge engineering in first order logic. Okay, next we will start about what is meant by first order logic. So here first order logic contains 3 methods. First one is objects, and second one is relations, third one is functions. Here what is meant by objects, and what is meant by relations, and what is meant by functions. So after seeing these 3 definitions, we are going to relate these 3 type of definitions to create the logics. That is the first step. So the first one, object. Here the object means people, houses. So normally the numbers, theories, colors, in real time what we are seeing the objects. So the general contain the objects. And relations, for example here we are considering 1 plus 2 is equal to 3. Here one is called as objects, and the relation is plus, and the equality is called as a function. So it is called as 1 plus 2 equal to 3. It is a simple example for object, relation and function. And second one, here we have given the example is red, round, prime, and some other example is given. And third one is the functions, father of, best friend of, third quarter of, one more than, beginning of. These are all the examples of functions. So here we are going to relate these 3 methods to create the first order logics, right? Next we are going to see about the logics in general. So here we have 3 logics in first order logic method, and another 2 methods is knowledge representation. The first one is propositional logics, contains fact, and the method is true or false method. The same first order logic and temporal logic also contained fact and object relations. The same commitment is true or false method. Temporal logic also contained facts, object, relations, and times. The same true or false method. And next one is we have a probability theory. So here we are going to discuss about the given sentence is whether it is right or wrong. So going to discuss about fact and belief. So whether we are going to believe that fact or not. So if going to believe means we have to put 1. So otherwise the given sentence is wrong means, so we are going to mark as a 0. And fourth one is the fuzzy logic. So here we are going to identify the degree of truth, and the epistemological commitment is the known interval value. And next one is, so we have given the one examples and the syntax of first order logic. So the next one is we have given the 16 types of syntax what we are going to use about in first order logic. The first we have given the constant and predicates, functions, variables, connectives, equality, and quantifiers. So here the quantifiers, we have 3 types of quantifiers. One is the nested quantifier and the existential quantifier, and another one is there exists quantifier. So these are all the 3 types of quantifiers we are going to use in the first order logic, right? The next one, so what are all the components we are going to use in first order logic? The first one we are going to use about tame and atomic sentences and the complex sentences. So the tame means, so we are going to take the tame from the object. For example, we have seen that the red is the object, function of constant is example color, block 1. Then atomic sentence is one, we have given one example, predicate relating to objects. For example, we are relating the brother of John and Richard. So here we have a John and Richard, both of the brothers. And next one, married, mother John and father of John. And complex sentences, atomic sentences plus logic connectives. And next one is, we have given quantifiers. Here each quantifier defines a variable for the duration of following expression and indicates the truth of the expressions. So the next one, what is meant by universal quantifier and what is meant by existential quantifier. The universal quantifier is the expression is true for every possible value of the variable. So we're going to call as for all. And second one is the existential quantifier is that exists. The expression is true for at least one value of the variable. And the next one, we have given the sentences are true with respect to model and interpretation. I mean the what symbol we are which symbol we are going to use to declare the true or false statements. So likewise we have given the three symbol, constant symbol, predicate symbol and function symbol. And the next one, we have given the one example to describe the first order logics. So here we have a person and on head. So the on head denotes the person's objects. And next one, we are using the universal quantification. And next one, we are using the existential quantification. And another one is, here we have given the another common mistakes to avoid when we are using the first order logic in knowledge representation. Normally we will get two mistakes at the time of describing the connectivities with the person and the objects. So we have to avoid the mistakes. And next one, we have given some examples to describe the first order logics in knowledge representation. The first one, so everyone likes a McDonald's, and another example is everyone likes ice cream. So the everyone called as for all x. For all x means everyone likes McDonald's and likes ice cream and likes chicken and mutton, non-veg or vegetarian foods. Likewise everyone likes ice creams. The next one, someone likes McDonald's. So for to describe the someone, we are using the symbol is there exist. There exist denotes for someone. There exists x likes McDonald's. There exists likes ice creams. And next one, all children likes McDonald's. So describe the all children, we are using the for all symbol. And next one, everyone likes McDonald's unless they are allergic to it. So here the sentence is everyone likes McDonald's unless they are allergic to it. So to describe this one, for all x likes McDonald's and allergic x comma McDonald's. So this is the simple representation to describe the statement of everyone likes McDonald's unless they are allergic to it. And next one, we have given some examples of properties of quantifiers. The for all x and for all y is the same as for all y and for all x. There is no difference. And next one, for all x, for all y is the same as for all y and for all x. And next one, we have given the one more example, for all x, for all y loves x comma y. There is a person who loves everyone in the world. So it describes the sentences. To describe the sentences, we are using for all x and y loves x comma y. And the next sentence is everyone in the world is loved by at least one person. So describe the sentences we are marking for all y there exists x loves x comma y. And we have one more quantifier is called as the nested quantifier. So in this nested quantifier also we have given some more examples. The first one, everyone likes some kind of food. So to describe the everyone likes some kind of food, so here we have given the for all y there exists x comma food comma x and likes y comma x. And second one is there is a kind of food that everyone likes. So to describe the sentences we are using the knowledge representation is for all x there y food x and likes y comma x. And the next one is someone likes all kind of food. So here we are going to describe the someone is for all x and there exists y. So everyone's like all kind of food. And next one, every food has a someone who likes it. And we have given some examples. So we have some fun with sentences. The first one is a brother with siblings and sibling is symmetric. Next one, other commands about quantification. So here we have given some sentences. So it is related to the existential quantifier and nested quantifier. the first one is to say everyone like McDonald's, the following is too broad. So we are using some other method that is called for all x likes x comma McDonald's. The other method is likes McDonald's, and next one we mean everyone who is human likes McDonald's. So for all x person, the person is denotes as everyone likes McDonald's. So this is the another method to describe the sentences. And next one, essentially the website of the rule declares the class of the variable x. Constraints, like they are often called domain constraint. So here we are going to add one more method that is called as the domain constraints. So the domain constraint is one more method of syntax and semantics of first order logic. And next we have given another method, equality. We allow the usual infix operator father of John equal to Henry for all x siblings x comma y x equal to y. Generally we also allow the mathematical operation when we need to describe the equality symbol for all x comma y, number of x, number of y equal to y plus 1, so that x greater than y. And next one, example domain. So we have given some example domains to create the syntax and semantics of first order logic. So we have given the first one is the Lipschitz domain and numbers and the Wumpus world. So we are going to create the knowledges for both Wumpus world and kinship domain. And next one, interacting with first order logic and knowledge base. So once we have created all the sentences, so we are going to interact with knowledge base, because already the agent gives some more informations to the knowledge base. The knowledge base only knows the where we have to interact with the world. So the knowledge base contains some information about the world. So the particular agent going to interact with knowledge base. So to interact with the knowledge base, so we needed two rules. The first one is called as the fact, second one is called as the rules. The first one, tell knowledge base to the person. So here we are going to discuss about, so I am the person, so I am, for example, I am the agent, so I have this type of environment, I am going to act in this world. So we are going to inform this information to the knowledge base. So after that rules is predicted, so after that ask questions to the knowledge base. So already some fact is stored in the knowledge base. So again a knowledge base stored some variables. So mainly we are using the two types of commands in knowledge base, tell and ask commands. So the tell command used to represent the what are all the environment stored in the agent, and ask command is used to describe the statements, and again we are going to store the information about the particular environment. So these are all the informations about knowledge representation using first order logic. Thank you, Ananda.